Hi, welcome to chapter number 20. We will talk today about carboxylic acids. My name is Ramon Rios. I am professor in organic chemistry. And this is a recorded lecture to help in your study. Remember that this recorded lecture, in any case, is a substitution of the attendance in the lecture room. Okay, remember that attendance in the lectures is mandatory in Khalifa University. What we will do in this chapter, basically, we will name carboxylic acids and we will check the structure and properties of carboxylic acids. How we name carboxylic acids basically is very similar to the nomenclature of aldehydes. Okay, first of all, like aldehydes, carboxylic acids can only be in the first and the last position of the chain, of the carbon chain. Okay, and we need to take as a major chain the chain that contains the major number of carbons with the major number of carboxylic acids. Okay, again, if we have this compound, a compound like this, sorry, the main chain will be the chain that contains the two carboxylic acids and not the chain that contains the major number of carbons. We need to contain the major numbers of carboxylic acids. Okay? Then, what we do is to check the major chain. We name the major chain, for example, methane, propan, ethane, etc. Okay? And this time, in order to show that it's a carboxylic acid, what we do is to remove the A. For example, of methane, we remove the E, and we add methanoic, the suffix oic acid. Okay, that means that, for example, the one carbon carboxylic acid will be methanoic acid. Here we have, this is the major chain, free carbons will be propanoic acid. And the next step is to put the substituents by numeration, always putting the numeration where the carboxylic acid has the lower number. For example, here we have we have to start from here in order to have the acid as a number 1. This is a 5 carbon chain. This will be a pentanoic acid, and then we put the substituent, that is this methyl in position 4, will be 4-methyl pentanoic acid. Remember that the substituents are by alphabetical order, etc., the same that we explained in each chapter. Here, what we have is a 1, 2, 3, 4, 5, 6, 7, 8, 9, is a 8 dicarboxylic acid. Okay, that means a priori for the carboxylic acid we can start numbering for each of both sides. Then we need to check the substituents. The substituents, we have this in position 3, this in position 6. If we do it opposite, we will have this in position 3 and this in position 6. Then we choose the bigger substituents in the lower position. That means we will start here because the ethyl, that is the bigger substituent, has the lower position. Then we put the substituents, that will be a free ethyl, 6-methyl, remember, alphabetical order, and then octane dioic acid. Why dioic? Because we have two acids. Like in the case of aldehydes, okay, when the carboxylic acid is directly attached to a ring, we will name the ring and we will put at the end carboxylic acid. Instead of carbaldehyde that we did with aldehyde, we will put carboxylic acid. For example, here we name the cycle. The cycle is a 4-hydroxy, because remember that this is position number 1, where is the acid. It's a 4-hydroxy cyclohexane carboxylic acid. Next step, we need to put the stereochemistry. In this case is trans, because the carboxylic acid is going down and the hydroxyl group is going up. That means will be a trans 4-hydroxy cyclohexane carboxylic acid. Here this will be a cyclopentane carboxylic acid, but we have a double bond in position 1. That will be a 1-cyclopentane carboxylic acid. Okay, well, we can name the following compounds. First one, we have the main chain will be a 4 carbon, will be butanoic acid, and then we put the substituent. That will be, we start counting from the acid, 1, 2, 3, 3-methyl butanoic acid. Next one, we have here the main chain that will be 1, 2, 3, 4, 5, will be a pentanoic acid. The bromine is in position 4, because remember, we start counting from where is the carboxylic acid. This will be a 4-bromo pentanoic acid. This one, the main chain, will be this. Okay, remember, has to be the major number of carbons that contains the major number of carboxylic acids. Will be this, is 1, 2, 3, 4, 5, 5, will be pentanoic acid, and then we put the substituent that will be this ethyl in position 2, 2-ethyl pentanoic acid. Here again, the main chain will be this, is 1, 2, 3, 4, 5, 6, is a hexanoic acid, but we have a double bond in position 1, 2, 3, 4. Will be a 4 hexanoic acid. Okay, where the N is coming from the double bond. What more? I have to check the stereoselectivity. That means that this double bond will be a Z. Z for hexanoic acid or cis for hexanoic acid. I can do the F. F is a cyclopentan, the major chain, and I have 2 carboxylic acid. That means I have to numerate because the first will be number 1, but the second could be any number. That means in this case it's number 3. 1, 2, 3, always the lower number possible. That means that this will be a 1,3 cyclopentan dicarboxylic acid. Okay, and finally you have to put the stereoselectivity information, that in this case will be cis 1,3 pentandioic acid. Okay? Good. Then, what are the properties of carboxylic acid? Well, the properties of carboxylic acid will become from the functional group. The functional group is not any more than a carbon bonded to an oxygen bonded to a hydroxyl group. In this way. That means if we check electronegativities, basically the carbon has to be electron positive, density has an electron positive charge, and the oxygen has to be electron negative. That means this molecule is polar. Moreover, because we have a hydrogen bonded to electronegative atom like the oxygen, this hydrogen will be acidic. That means that we have that this compound is dipolar and has hydrogen bonding. Remember that the hydrogen bonding is depending of how acidic is the compound. When more acidic is, more hydrogen bonding we have. That means for this reason, carboxylic acid will always be with a higher melting and boiling point than alcohols, for example, because they are more acidic. If someone is asking why are more acidic, it's because in the conjugate base, okay, this is the conjugate base, we can do this stabilization. We can put these electrons here, we can move, and we have this. Okay, this resonance form, that means that stabilize and make this compound more acidic. Right? Okay. Like in the case of the alcohols, if we add atoms that are very electronegative in the carbon chain, what we will do is to increase the acidity of the carboxylic acids. For example, if we add fluorines, we increase the acidity to the pK is around 0, while without fluorine, with hydrogens, we have a pK of 4.7, more or less. Okay? It's following the same tendency than alcohols. If we add electron-negative atoms, we are increasing the acidity. And that's all for this chapter, very short. Please do the study question from the book, question 1, 2, 6 and 17, and read the book, textbook chapter 20, points 1 and 2. Thank you very much for your attention and see you in the next lecture.